Hello and welcome everyone. My name is Neha Rungta and with me today is Neha Goswami. So you have not one but two Nehas and we'll be showing you what's the latest and greatest in proactive security. It's something that we've been building for the past few years and also past few months, sorry about that, and also been using within AWS. And I'm super excited that we are finally getting to share this with you. And here's our agenda today. It's all about proactive security. It's all about enforcing your security requirements earlier and earlier in the development lifecycle. And I do want to call out, a development lifecycle is not linear. It's this chaotic cycle, non-linear process. But the key is it's still going to be early in the process. And what that concretely means is bringing your security requirements into the design review, code review, as well as the penetration testing. But first, before we talk about that, we're going to go way back, way back, when light at night was a luxury good, when it was expensive and therefore rationed out carefully. Only the rich had access to light at night. And even then, it was used sparingly. That was until electricity was invented. Today, light is a commodity. It's everywhere, and that's changed what light means to us. It's no longer something that's exclusive, no longer means that it's something that needs to be rationed out. Until recently, proactive security has still been in the candle age, rationed out, used sparingly. But the invention of large language models has fundamentally changed that. It's now the electric age for proactive security. Today, we're going to see what a world of plentiful proactive security looks like. How and what can we do when proactive security is as common as lights in Vegas? When security design review is cheap and fast, that you can do it anytime, anywhere you want it. When security code review happens on every pull request. When penetration testing is on demand instead of a scheduling headache. Can I get my 3P to actually do the schedule? That is the AWS Security Agent. Security requirements are the foundation of proactive security. And we like to think there's, broadly speaking, two types of security requirements. First, there's industry best practices. These are things everybody should follow. These come from our collective knowledge as software developers, and they evolve slowly over time. And second, there are company-specific requirements that come from a particular domain. It comes from the industry domain. It comes from the countries that you operate in or the policies of the company itself. So as we begin, let's start with this industry-specific one because it will apply to everyone broadly. These are examples of general-purpose security requirements. For example, secure by default. This ensures that the system's default configurations are secure, and that it requires extra work, extra steps to move outside of the safe default. Traditionally, this is a design goal, but it's not enforced anywhere. It's hard to check during design time, is the system secure by default? And here, what we rely on is the knowledge and best intentions of our developers to stick to the goal. Because they have to know that secure by default is a goal, and then have to know, how do I check whether my system is being designed to be secure by default? In the security agent, we codify these best practices as AWS managed security requirements. Here, you can see there's about 10 managed security requirements, which we ship in the AWS Security Agent. You can take a look, when you go into the console, and here's the one we have for secure by default. In addition to a name and description, which are two of the critical fields, there is an applicability of this. Why does it matter? Why is it relevant? And one of the things that we found is that there is no shortage of security requirements. They're a dime a dozen. They're like, hey, you should eat your vegetables, you should eat your broccoli, they should eat your cauliflower or your spinach. Great. But why does it matter? Why does it matter to the particular application? And that's what this tells us. Second, we have a compliance criteria. What does it take for the service or the application to be compliant with that security requirement? This is part of the AWS managed security requirement. Now, let's take a look at how the agent uses these security requirements. And to do that, today we're going to use this fictional AWS service. You ready? We call the service the AWS Suites Manager. And let's run this design doc through the security design review process. Now, what would normally take hours, days, perhaps even weeks, can now be done in minutes. We start by creating a design review, uploading our design doc, and clicking Start Design Review. In minutes, we have our results. We can see which of the security requirements are compliant, which are not applicable, because context matters. Not all security requirements are going to be applicable to all applications. Which ones have insufficient data? Here, it doesn't have any, but for many, your doc may not have enough data to say, does it even matter? And which ones are not compliant? There's one here that is not, so let's dig into the details. Here it says the secure by default requirement is not compliant. Let's find out why. It is because one of the user-created resources, a box, is shared publicly by default. Here it is. It tells you why. It tells you why it is not secure by default. But then the agent also gives remediation guidance on how we can update the design doc to satisfy the security requirement. The advantage is now you've caught this early in your design phase before a single line of code is being written. Another feature is the code review. You can connect your GitHub repositories, and the security agent will review every pull request against the same set of security requirements, because some of the requirements may be applicable to the design part, and others may be applicable to the code. And where they're applicable to both, your evaluation will happen on both of them. Let's say a developer, or any of you, had a great idea for a new feature. Maybe it's so great that you don't even need to begin with a design review. I mean, I feel all my ideas are so great that I never need a design doc, and I can just start coding. And now with the coding assistance, it's become even easier. You can get started so easily. The security agent will read the pull request of this feature and flags an issue where only the created resource are shared by default, instead being secure by default. Great. That was an example of how we could do industry-specific best practices. The similar thing applies to company-specific requirements. These are very important because they are relevant to your organization. Now, your specific ones will depend on your organization. What's your business? Maybe you have requirements about how identities are granted access to applications. Or maybe you require a multi-party authorization, contingent authorization for sensitive resources. You may have specific encryption requirements. Audit logging, you can have a whole bunch of them. What types of data should be logged versus not logged? Whatever your particular security requirement, the security agent is designed to capture them. Let's look at an example of how you can specify one of your examples. Let's say you want to have encryption. Your particular security requirement is that post-quantum cryptography must be used. You can create this, and there are 4 main parts. very similar to the AWS managed ones. First, you need a name and a description. These are for your benefit so that it can help you identify the requirement and explain the high-level purpose. The second, very similar, is the applicability. Why does it matter? What types of systems does it apply to? Does it apply to all systems? Is it a global type of requirement? Or is it, hey, for this class of systems, these should be true? Third is the compliance criteria. What would it take for this requirement to be met? And this really is to help the end developers to know, what should I do to fix it? If you just say, this is broken, great. What do I do? How do I fix it? How do I get this to be compliant? And with that, you can say, maybe you can provide links to the internal documentation or even recommendations for particular libraries or services to use. I'm developing a web application. How do I know what credit card processing libraries is approved by my system? This can be a place where you can specify it once and every developer in the company can just use it out of the box. Once you've created your custom requirement, they will sit along right alongside the managed security requirements provided by AWS. And they will apply to all your design and code reviews going forward. Let's see how it does on our fictional service, the Suites Manager. Same as before, we upload our design document and start a new design review. In this case, we have one additional non-compliant security requirement. We are failing the new post-quantum cryptography requirement. What do? It's the same as before. You click on it, you look into the details of why the security requirement is not compliant and what we should do to fix it. It's telling me enough. I can do it. What about code review? Same thing as before. The new security requirement applies as much to the code review as it does to the design review. Here, we can see it flagging a pull request, which is using traditional cryptography instead of the post-quantum algorithm. Finally, I want to give you a look behind the curtain, how at AWS for the past few months we've been using the security agent. I've told you about company-specific requirements. Well, AWS is a company. We have our own internal security requirements, lots of them. And we've been using the security agent to capture these requirements and increase the velocity of our developers, applied to their design reviews, applied to their code reviews. Here's examples of AWS-specific security requirements. These are about how we build services to ensure that they are safe and secure for all of you, all of our customers. I want to highlight the last one here. This is how we, I wanted to highlight, sorry, I'm going to back. We launched an IAM integration library. Now, this is only applicable to AWS because services in AWS need to integrate with IAM. All services need to integrate with IAM. To help those service teams, we launched a new automated reasoning-based proven correct library to integrate with IAM. This is a remarkable piece of software. It's a core security primitive that we have developed internally for our teams to be correct, move faster. But how do we ensure that teams end up using it? The AWS Security Agent is a mechanism to ensure that all our service teams end up using this. It turns an intention, hey, all of us should really be using this library that's verified correct, that helps us move faster and gets everything done correctly, to a how in an organization, large organization with multiple teams, the AWS Security Agent says, oh, you should be using this library. And there it is. The Daffodil library, it's an internal thing. It's only applicable to teams in AWS. And now, it's an easy way for all teams to know about, hey, I need to integrate with the Daffodil library to make it easy for me to do my IAM integration. We've made some improvements to our design doc, but now it's failing this particular security requirement. Just like before, we can view the details of the security requirement and what we need to do to fix it. This quick, easy, automated design review has been a boon for our internal teams. Here is a quote from one of these teams after using the security agent on their most recent design review. It's really highlighting the power of proactive security. It's catching the issues early. We can fix them early, which means it's a lot faster and cheaper to catch issues before they hit production. We know as it gets harder, more expensive, the later you find an issue and when you fix it. We have integrated this also within our internal code review systems. Now, in AWS, most teams here don't use GitHub, so we've integrated the agent into Amazon's internal code review system. So the teams can get feedback during their code review processes as well. We've seen tremendous benefit from catching these issues early. It's helped the velocity of our developers. And these are not just some generic security issues. These are issues tailored to AWS's specific security requirements that we impose on our own internal teams. So, are we there yet? Have we left the candle age of proactive security? Not yet, because we are still replacing existing security reviews one-to-one with the security agent. And it's a good start, but it's still thinking of proactive security as a luxury good to be rationed out. It's like living in the age of an electric candle, an improvement, but it still leaves the world a very dark place. So let's look at how we are doing proactive security in ways we had never considered before. How is it actually transforming the whole space? Here is a feature request for a Suites Manager, the ability to share resources using resource policies. Maybe one of our engineers will go off for a week or two and write a design doc that we run through the security review afterwards. But why wait? And I know some of you are thinking, this is nuts, or I'm crazy, which could be both true, but I am serious. Why can't we do a security design review of this feature request as is? Okay, let's try it. Let's upload this to the security agent. Look how tiny it is. Is there anything even worth reviewing here? Apparently so. Now, most of our security requirements are either not applicable or do not have enough data, which is to be expected, given what's the input we gave it. But one of our security requirements is already not compliant. This is block public access. Looking deeper, we know AWS requires that all new resource-based policies require block public access. For any of you who've used S3BPA, you can turn it on with one click to ensure your resource is not public today. It's not going to be public anytime in the future. A lot of the services support it. And it's a requirement for all new resource policies to support that. Now, this is huge. Instead of spending weeks designing the feature before finding out that this critical requirement, we now know before we even get started. This is what proactive security means in the electric age. I'm going to look at one more example. The previous example was about a super short form content. So what about super long form content? For this, I want to tell you a funny story, and it's a funny story that is true. I've been talking about the Suites Manager example as this fictional AWS service, but the truth is, We built it back in 2023. It was used as a demo application. We are all about dog fooding our own services and features, so we built the Suites Manager as a way to see how easy is it to use our own services? What would we do to build an application for various features and integrations? And it actually works. You can create a box of suites, share it with people. You can even share the box of suites with Andy Jassy, our CEO. That's what the application does. It's a full application. And as part of this, one of our engineers had an hour-and-a-half meeting and walked through it, how it was created, what were the different services that were used, what services worked well, what were the pain points as an end user while developing the application, explained where the pain points were, what was easy, what was hard. So we had an idea. Why not see what the security agent thinks of this meeting? So we uploaded the transcript and created a design review for it. There we go, the transcript for that meeting. And here are the results. Most of them didn't apply. Again, not surprising. But I was interested to see what actually failed. The meeting was non-compliant for best practices around secrets protection. Let's see why. It looks like there's direct usage of sensitive credentials without proper protections in place. Now, this is not unexpected for a demo meeting, but a fair point nonetheless. These are not things that we would have thought of to do a security review, a feature request, a meeting. This is creating the transformation in proactive security. As strange as these cases may sound, this is what moves us out of the electric candle age to the one that we live in today, into the electricity age, when proactive security is used in ways that none of us had even imagined yet. That is the power of the AWS Security Agent. Now, I talked about two parts of it, the design and the code review. And to keep the electricity flowing, I want to invite Neha Goswami to tell you about how the security agent does penetration testing.
Thank you, Neha. Hello, everyone. I'm Neha Goswami. I worked with Neha on this security agent for the last few months, not few years, and it has been a fun journey. And continuing the theme of electricity age, going from a candle age to an electricity age, I want to talk about pen testing and describe how that candle age to electricity age transition has happened for pen testing. So even in Amazon, pen testing happens very late in the development cycle today. Developers have already done the work to identify what they want to build. They've written the code's checked in, and your feature's ready to go live. And that's when the security team is engaged to do pen testing today. And it's done by a dedicated team, love our security team, love our security engineers, but we always hate the fact that we now have to wait a few weeks for them to finish their work. So why do we have this process today? This is what I'm calling the candle age. The expertise for pen testing is limited, so a lot of companies are outsourcing this work to other companies which are specialists to do this. What else is the candle age? It's a really slow process. As I said, it comes at the end of your development cycle, and you have to engage another team to do it. These pen tests need to be scheduled really early. There is a lot of calendaring time that gets absorbed in this. And the last thing is, even the pen testing companies themselves end up giving you some very basic vulnerabilities that you could have maybe easily caught ahead of time. So the value itself by the pen testers is not as high as dev teams are expecting. And this is something we hear from customers too. So it's not just an internal Amazon observation. This comes up in our conversations with real customers as well. They have to do all the scheduling ahead of time, and they're finding that the value, again, is very limited because DAST scanners are doing a lot of this work already. And the connection between the vulnerabilities detected and the kind of logic that is in the application is not always great. So let's talk about the electricity age. The AWS Security Agent makes pen testing easy and on demand. So you don't have to wait for another team to actually conduct these tests. Call them ahead of time, schedule them, get on their calendars. You don't have to do any of that. You can actually run it as and when you need it. It's very fast, so it's not going to take months or weeks. For us, it's been weeks forever that this process takes for complex applications. And now we can execute it in hours and days. And that's very, very powerful. And the third one, which I talked about, the DAST tools, which are giving you very generic vulnerabilities, you get a lot more relevant results when you use the pen testing agent, because it takes in the application context, it takes in the design document that Neha talked about, and you can upload all sort of details about your application for this agent to use. I think for any of you who heard Matt Garman talk about agents yesterday, he talked about frontier agents. Frontier agents that run autonomously, that handle very complex tasks, and that need little steering. AWS Security Agent is one of those frontier agents. And I will take you behind the curtains on how we do pen testing, and you will see how and what makes it really a frontier agent. So here's how it works. So the pen testing agent will take inputs. One is your API endpoints that you are trying to test. The other is the credentials that you need to log into that API endpoint, a bunch of documents which are relevant to your application, and code repositories. It will take all of that and run through the pre-flight step. What does the pre-flight step do? It basically just checks that endpoint to make sure it can authenticate and log in. And it creates a site map because you've given it a lot of application context. Based on that, it creates an understanding of the application. Feeds all of that information into the planning agent. The planning agent is nothing but an orchestrator and a coordinator of sorts. It starts to execute multiple pen tests in parallel. All the pen testers that are running in parallel will take the findings and feed that into a validation agent. The validation is a super important part of our workflow over here that actually checks to see which are real vulnerabilities and which are the ones which which seem like false positive, essentially. So it does a lot of filtering to make sure that the findings are relevant and the findings are correct. And here is where our agentic loop begins. We feed our findings back into our agent, and we look for corrections till we arrive at a state where we are fairly convinced that our findings are real and our findings are relevant. Then we feed all of them into the remediation agent, which has the job of basically telling you now what to do to fix these vulnerabilities. And we feed that back into your code repositories so that the PR is generated for your dev teams, and they can just review it and check it in. So now I want to show you what this really looks like if you're using the pen test agent. So this is the target URL screen where you can describe whatever the endpoint is that you're trying to test. It's pretty straightforward. We ask for a bunch of information here, but you'd notice most of that is optional. We've tried to keep it super low, low weight, very easy to invoke. So you can literally just give it the target URL and get the agent to go to work. You do have to give it the credentials because most of the applications require some sort of a login to go and access the endpoint that you're giving. and the design documents that I talked about. So oftentimes your applications has some design document, even the requirements document that your engineers might have written, anything which you think is going to be useful for the agent to draw its conclusion, we allow you to add that as an optional resource. And the last thing here is really the code repositories. This is to get more application context, but also generate pull requests for you at the end of the cycle. And this is it. This is all you need to configure it. And now you just press the run. As the Pentest agent runs, as I said, it is a long-running agent, so it can take hours. Sometimes it can take days. In our experience, mostly it's run for hours to find the vulnerabilities. And here you can track it in real time. You can see how long it has been running, and once it's complete, it will show you the status right here on that screen. So here you can see the results that the pen testing agent publishes. And what is interesting here is that it will categorize the results for you. So it will tell you how many are high risk, medium risk, and that categorization is super helpful because typically, again, in a security review, you get a bunch of findings, and your engineers are then focusing on what is the most critical one that I absolutely must fix before we deploy this to production. What is a low-level risk that I am okay taking, which I can fix as a fast follow? So this sort of categorization is super helpful for not just the security team, but also for the engineers who are then making the fixes for these. And over here, you can see what the agent has done in order to do pen testing. It's actually gone through a bunch of other URLs and basically exercised what your application is doing in order to really execute the pen testing. So you kind of get a flavor of what it has done behind the scenes, and you'll get a much more in-depth look into that in the next screen here. So here is the summary that the pen test agent has produced. And let me just share with you that this is the page where we got the most positive feedback from our own internal security team and from the customers. This, and even if you read the log, I mean, it's hard to read on this screen, but it's just raw logs. But it shows you how the agent conducted the test. How did it arrive at the fact that this is a critical finding? And that step-by-step breakdown has been super useful for customers. They take hints from here, and sometimes they will go and conduct some other tests, and that has been a great workflow that we have seen. And other times they're just like, okay, it is super clear to me how this agent has done its thinking. And I can now validate it and feel more confident that the results it is giving me are truly the right results. Now, I think if you just focus on the particular one we are highlighting here, which is the privilege escalation task, the logs, which again, you'll see on the top, they will just tell you, the agent will tell you the way it proceeded. I executed this step, then I did this next thing, and then I did next thing as this step. So I think just that level of detail is pretty remarkable to see. And I was talking about the DAST tools earlier. I think if you really look at what has been done here, this is just reasoning which is happening behind the scenes. None of the DAST tools do that today. So this, for us, was the truly remarkable part as the builders of the tool when we could see the agent doing this work. Again, something which our customers and internal teams really, really loved, the steps to reproduce this. So the agent has done this work, but what if our team wants to rerun what the agent has done to build that confidence? And we really needed that early on in the process with our own security team because they were building the confidence that they can start to use this tool in production. So this set of steps, again, was super useful for our own team to just start to get confidence that the agent is working as expected. And this was part of our validation steps. So the agent actually has a bunch of other things that it is executing to make sure that the findings are the right findings, and we are able to reduce the false positives as much as we can. And there's just a lot of work that has gone in this part of the system to make sure the right findings are surfaced. You get a very detailed level of risk reasoning over here. Again, part of the things that people really loved about the tool. And my favorite part was the remediation part. So yes, you have found out what's wrong with the application. Now what do I do with it? And this is where the magic is. You can see the magic. This is what makes it electricity, if you were to ask me. You have pull requests generated right here to say how to fix the problems that the agent has identified. And this is how you meet the development velocity of your engineering team. And with more and more code that is being written by coding agents, you've seen that part of the SDLC, the actual coding building part, has really taken a leap in terms of just the speed. So teams are generating code at pretty high velocity now internally for us. Same thing is happening in the industry. So we don't want security to become the bottleneck. So the fact that this agent can actually do the remediation, you can run it on demand, and it'll generate pull requests for you. You are able to keep up with the development velocity of your engineering teams. And here you can see the runs that the Pentesting agent has done. So whatever has been done in the last week is visible to you here. Again, one of those things which our teams have found very useful as a visibility mechanism. And coming back to what I was saying, this to me, the design review, the code review, and the pen testing part combined is the electricity for proactive security. You get very, very application or business aware results from all three tools. You can run these on demand. You can run code reviews right when you check in the code. You can run pen testing at a certain point in your workflow. You don't have to schedule these ahead of time. You will get to see the work of the agent in detail as the agents do their work. And the results are very comprehensive based on our own internal testing. And here are some quotes just on that part. What have teams found when they have used the pen testing agent specifically? And again, it took us months to get here. It took us a lot of work to make sure the agent was accurate and giving us findings that were truly correct. And we're very happy that we arrived at this stage where we can share this on stage with you. But it took a lot of cycles for the team to do that. Also some quotes from SmugMug and Henge, which are our external customers. SmugMug was actually super interesting for us because they ran the Pentest agent, and the agent found actually a business logic bug is what they called it in their code, production code, and they were super excited about that because it's just one of those things that had gone unnoticed. All right, to wrap up, today we covered all three aspects of security, proactive security, that AWS Security Agent provides today. Again, I'm super excited to bring this to the world. We jumped on this endeavor earlier this year. High ambition team and a very hard task in front of us. So we are very proud of the work the team has done. And there's just a lot of knowledge that has gone into making this product as robust as it is today. You can actually give it a try. It's fairly easy to get started on this. Very minimal configuration steps needed. So I'll highly encourage you all to go and give this a shot and give us any feedback that you have. We would love to hear that. All right. Thank you all.